Engineering notation is very similar to scientific notation, except our exponents are always going to be a power of 3. Why do we do this? It's because when we talk about there being roughly 37,000 people living in Oregon City, I should say, we say 37,000. We don't say 3.7 times 10 to the 1 or 10 to the 10,000. We simply keep it in thousands. We talk about how many millions of people are in New York City, how many billions of people are in the world. These are all powers of 10 to the third power. It also helps us to convert between different metric units when we're talking about powers of 3 in our exponents. So that's why engineering notation is important. It's especially important to those of you who are going into an automation engineering field or are in HVAC when you have to convert between kilo, mega, milli, micro, nano. Anybody that's dealing with electronics too, a lot of those smaller units are also in powers of 10 to the third. So this is actually an important concept to learn and one that many of us don't know about. With these examples, we are going to write the number in engineering notation and then in scientific notation, just so you can see the difference. First example, the US population is around 330.2 million people. How would we write this in engineering notation? Now, if we look at our definition of engineering notation, instead of our first number having to be between 1 and 10, it can now be between 1 and 1,000, but it has to be strictly less than 1,000. It can be 1 digit, 2 digits, or 3 digits long to the left of the decimal point. This is currently 3 digits long to the left of the decimal point, so we can leave 330.2 times 10 to the what? Well, we can look up here, 1,000 is 10 to the third, 1 million is 10 to the sixth, so it's simply going to be times 10 to the sixth. How would we change this to scientific notation? How does scientific notation compare? Let's see. So in scientific notation, we can only have a decimal place after the first digit. So this would have to be 3.302 times 10 to the what? We move the decimal place 2 spots to the left, so we have to add 2 to our exponent. So we'll have 10 to the 8th. I'll have you guys work on problem 11 on your own, but I wanted to also show you problem 12, talking about how engineering notation is going to be helpful when you are performing conversions. And we're going to perform more conversions later on in this unit, and you'll see why it's going to be helpful. So we have to figure how many meters are in 1.26 megameters. So let's look up in our table. Mega is 10 to the sixth. So there are going to be 1.26 times 10 to the sixth meters in a megameter. What is that in decimal notation? How many times do we have to move this decimal point? 6 times. 1, 2, 3, 4, 5, 6. So we're going to have to add 4 zeros to the end. Put our commas in to make it a little easier to read. 1,260,000 meters. Which prefix will make, how many is that? hundreds, thousands, millions, 17,528,000,000 liters read most simply. How many times can we move this decimal place for the first number to be 3 digits or less? Well, we can move it 3, 6, 9 places. So if we take 17.528 times 10 to the 9th, what is that going to leave us? Where's 10 to the 9th on this table? It's right here. So it's going to be 17.528 gigaliters. It's a lot of liters. At this point, I'm going to have you stop, take a look at problems 11 and 13 on your own, and see how you do.